Okay, this is section 3.3 video, part 4. If you will, pause the video now and copy this. Okay, you should have that. Now, hold up just a second. Okay, pause the video now and copy this. All right, now let me go over this one problem, and this will close out this video. The last 3 or 4 problems in your homework, it was something like this. Okay, what we're doing in this particular problem right here is we're doing 3 things. There's an A, B, and a C part. First, we've got a 3rd degree polynomial. The first thing we want to do is list the set of possible rational zeros. So we're listing our suspects, if you will. Okay? Then after we do that, we're going to carry it a step further. We're going to get in that list and check it till we find the zeros. And remember now, excuse me, in this video, when you're looking for your zeros, you don't have to find all 3 with synthetic division. You only have to find 1. I'll mention that again in a minute. And then we'll write out the linear factors. Now, you can do the zeros or the factors first, either one, because you find them all at the same time. Remember, if 7 is a 0, x minus 7 is a factor. If x plus 8 is a factor, negative 8 is a 0. So you find the zeros and the factors at the exact same time. All right, so here we go. Let's do part A, the possible rational zeros. So this is plus or minus C over L. What is C? C is all of the numbers that go into 6. 1, 2, 3, and 6. L is all of the factors of the leading number, which is 2. The only numbers that go into 2 are 1 and 2. And remember what I told you to do was I said circle the 1. So it's 1 over 1, plus or minus. 1 over 1, 2 over 1, 3 over 1, 6 over 1. That's where these come from. Now you mark the 1 out. Now, put all of these over 2. 1 over 2 is a half. 2 over 2 is 1, I have it. 3 over 2 is 3 halves. 6 over 2 is 3, I have that one. So I have 1, 2, 3, 4, 5, 6. There's 12 numbers in this list. 6 positives and 6 negatives. All right, so that's the answer to part A. Now part B. Find the zeros. So this is where you start doing synthetic division with only these numbers. So I don't want to do synthetic division with 4. It's not in here. I don't want to do synthetic division with 5. It's not in here. So I only want to do synthetic division with just these numbers. Now, I would suggest that you try the negative 1 and positive 1 first. Then the negative 2 and positive 2 second. But I have had some students that want to do 1, 2, 3, 6, negative 1, negative 2, negative 3, negative. That's the way they do it. That's strictly up to you, which pattern you decide. I did tell you in the last video, I will make sure that one of the whole numbers works. So you're not going to have to try the fraction ones, just for the sake of time. So if you try these first 4 whole numbers and they don't work, you've made a mistake. Now once again, in part A, I want the whole set listed. All right, so here's what I'm about to do. I'm going to try negative 1 and positive 1, negative 2, or in any order I want to, but I'm about to try these. All right, if you'll notice, I tried negative 1 first, and it didn't work. Got 2, negative 9, 13, negative 6. Where did those numbers come from? That was the polynomial that you were given. So I tried negative 1 first. Brought the 2 down. That's negative 2. That's negative 11. Negative 1 times negative 11 is 11. 13 plus 11 is 24. Negative 1 times 24 is negative 24, so I get negative 30. So no, negative 1 is not a 0. So that means x plus 1 will not be a factor. All right, so I tried negative 1. Now I'm going to try positive 1. All right, bring the 2 down. 1 times 2 is 2. Negative 9 plus 2 is negative 7. 1 times negative 7, negative 7. 13 minus 7 is 6. 1 times 6 is 6. Negative 6 plus 6 is 0. Okay, couple of things. First, since my remainder is 0, that means that 1 is a 0. That also means x minus 1 is a linear factor. Now, what did Part B and Part C say do? Part B and Part C says find all of the zeros and all of the linear factors. So we have only found one 0, 1, and we've only found one linear factor, x minus 1. But we need to find the other 2. Now, this is what I was making reference to a while ago, but I want to say it again here. In any third degree polynomial, once you find the first 0, you can stop. Here is why. Look at this answer right here. This answer right here is a quadratic equation. It's a second degree because you've done synthetic division on it. So now this is a second degree. So this is 2x squared minus 7x plus 6. So we've got 2x squared minus 7x plus 6. Now what I want to do is I want to factor this. There's no GCF. This is not the easy case. This is the Brew method. So when I factor this by using the Brew method, this is what I get. So here are your other 2 linear factors because we factored it to get this. Now, how do you find your other 2 zeros? By setting this equal to 0. If in your head, you can do that. If you set x minus 2 equals 0 and add 2 across, you get positive 2. Now, to get the other 0, set 2x minus 3 equals 0. Add the 3 across, but then you have to divide by 2. So here are your other 2 linear factors. Here are your other 2 zeros. So, what are the zeros? 1, we found that by synthetic division. 2, and 3 over 2. Now you say, Mr. Randall, what would happen right here if that wouldn't factor? 2 things. Number 1, I will make sure that the one I give you will. So it will factor. But if it did not factor, you could use the quadratic formula to find your other 2 zeros. But I will not give you one like that. But that's what you do if you couldn't find the other 2 zeros, quadratic formula. All right, so we've got 1, 2, and 3 halves. And then the factors, 2x minus 3, x minus 2, and then x minus 1. In any particular order, it doesn't matter. And if you was to multiply these 3 things out right here, it should take you right back to where you started. So this completes section 3.3 video, and this is actually part 4 video.